All right, let's get started. Section 18.2, page 262. I will start reading at the top. You can follow along. Clarissa is one of the surveyors hired to help determine land boundaries. She needs to find the distance across a ravine. She thinks she can use properties of similar triangles to find the distance. She locates points A, B, C, D, and E and takes the measurement shown. Okay, let's look at this picture up on the board. So what's in your book? She's trying to find this ravine distance. Put an X there. Do you guys see a difficulty in trying to measure that? Have you ever seen a tape measure cross a ravine? Or if you get in a boat and try to measure, that's going to be kind of tricky because you might sway and not really a good way to measure that distance. So here's what she does. She sets up a similar triangle and then does a measurement. Set your pencil down. I'm going to make up some easy numbers for you to get an idea of what's happening, and then we'll work with the actual numbers. Let's pretend that the distances are 10, 20, 30. And we know, let's say that this figure is maybe 3 times as big. Well, if these are similar, and this one's 3 times bigger than this one, wouldn't this have to be 3 times 30 or 90? See what I'm saying? This is what she's doing. She can't measure X, but if she can figure out that there's a relationship between this triangle and this one, she will be able to use these numbers to figure out these numbers. So we have to make sure they're similar first. Question 1. Which similarity criterion, if any, can be used to show triangle ABC is similar to triangle DEC? Yesterday we talked about the similarity criteria or criterion. There were 3 of them. 3 ways prove triangles are similar. They were at the top in a box. 3 ways. What were they? AA. Write these down, please. Your 3 options: AA. SAS. Very good. And SSS. Yep. Meaning, if these 2 triangles share 2 congruent angles, they're similar. If they share 3 sides that are proportional, they're similar, or sort of a combination of. We want to see if any of these is going to work for these 2 triangles. I definitely know this isn't going to work because I don't see 3 side lengths listed for each one. I don't even see 2 sides listed. Here's a side here and one here, but I only have 1 there. I would have to have 2 sides of this triangle and 2 sides of that triangle. So if they're similar, AA is going to be the only way to go. Does anybody see 1 set of angles that are the same?
Vertical.
Very good. Let's mark these vertical. We don't want to call it angle C, so we'll give it a 1, 2. Angle 1, congruent to angle 2, vertical. Raise your hand if you also notice vertical. Good, good. Okay, so that is 1 set of angles they share. This one says 64. I don't see a 64. This one says 64. Okay. What do all angles in a triangle add up to? Yell it out. 180. So take your calculator. Everybody. 180. Subtract these 2 that were given to see which one you have left. Lily, let me know what you get.
I got 55.
I did too. Let's put 55 in your picture. And since we have 2 with the same number, let's mark those. I'll do a double arc. I've already done a single arc. And my work will say angle E can go to angle B. My reason, they're both 55. For an answer of which similar criterion? AA similarity. That is how we do number one. Which similarity criteria? So which of the three that Jaden mentioned, in this case AA, and you have to say which set of angles, here's one, which other set of angles, here's another. Number two. Ignore number two. We're going to do our own number two. You guys have an X here, correct? We're going to solve for that. We know they're similar, so there's a relationship between this triangle and that one. We're going to pick a pair of sides that match up. Cam, pick a number anywhere on the board that's for a side. 55? 85. Okay. 85. You can start with any side number. You decide to go with 85. I need to compare 85 to one of the numbers in this triangle. Don't just guess. Here's how you figure it out. Look at what I call the landmarks. What is 85 next to? 85 is next to the red vertical angle and the angle that's not marked. Is that this one? No. Is that this one? Yes. 65 is next to the red vertical angle and the angle that's not marked. So 85 is in the same place as 65. Write that down. Did that make sense? What they're next to. This is next to two angles, a red angle and an angle with no markings. This one, a red angle, no markings. Equals. Now we have to pick another set of sides that go together. Because he chose to start with 85, we have to stick with this triangle. Great, let's do X so we can solve for X. Now there's only one number left, but let's make sure they go together. What is X next to? It is next to the blue double arc and no arcs. Look at 55. Blue double arc, no arcs. So they do go together. This setup is half the battle. It's difficult to do this. You have to slow down. Do we understand there's a lot of ways we could have set this up? Cam could have picked any number. But once he picks one, we have to do it that way. We have to pick what goes with 85. And since he picked 85, this figure first, I got to pick that figure first again. All right, cross multiply on your own. Go ahead. You can round to tenths or hundredths unless the directions tell you otherwise, which they don't. Let's not round to a whole number. That's kind of lazy. So we've just figured out. No, it's T. It's even worse. T is terrible. We just figured out the distance across the ravine is 71.9 meters. Check, make sure that seems reasonable. I think it seems good. It's not like 200. That would seem way too big for the other numbers we have. Let me read the paragraph at the bottom of 262. Clarissa measured the length of the ravine indirectly. Indirect measurement is a technique that does not use a measurement tool, such as a ruler, to measure an unknown length. Indirect measurement is used to measure distances that cannot be measured directly, such as the height of a tree or the distance across a lake or a ravine. Triangle similarity is often used to make indirect measurement. Exactly what we just did. We indirectly measured this without a tool. We knew these were similar, so then we compared one to the other, one side to the other side. On page 263, you see an example completely done for you. We're not going to spend time doing that. If you want another one to look back at, look there. We're going to do the next page, example A. Turn the page, 264, the very top. It says to find CB. I'm going to put an X there for CB. What we need to do first is make sure these triangles are similar, so then we can compare one side to another, one side to another. So let's see if we can go with AA. Here's an angle that's marked. Here's an angle that's marked, so let's call them 1 and 2. Do you see why you can't call it B? Could be B. A is fine, but not B. So let's go with angle 1 congruent to angle 2 given. No other angles are listed. Do you guys have an idea? This came up yesterday. Maybe if I highlight it, it will help. Here's the blue triangle. It has 3 angles. And here's the green triangle. We know this one is in common. I don't really know about that one. Yeah. They overlap. They must share it. Even though we don't know the number, they're exactly the same because they're right on top of the other. So we'll say angle C congruent to angle C. Nora, do you remember what that's called when they exactly overlap? Reflexive. Good, reflexive. So the triangles are similar, AA similarity. It might not seem important to do this before the numbers, but it is important to make sure they're similar. Otherwise, you could be comparing 2 objects that should not be compared because they have nothing in common. Alrighty. I let Cam pick a number. I'm going to let somebody else pick a number. But there's one number I don't want you to pick. That's the 12. Can you see why I don't want you to pick 12? Is 12 a side of this blue triangle? No. Is 12 the side of a full green side? You see what I'm talking about? This 12 is only this little piece. So don't pick 12. That is not a full side. Kevin, pick a number. 20. You know what we might want to do? Let's label C with a double arc. Might help us match some things up. He picked 20, so go to see what 20 is by. 20 is by a single arc and no arcs. As is 35, a single arc, no arcs. This one is set up nicely. Now, since we started with 20, the blue small triangle, we have to go back to the small triangle. So let's go with X now. X is by or between the single arc and the double arc. And this side is between the single arc and the double arc. How big is that side of the triangle? What? Good guess. It's 12 and x put together. So it's just simply 12 plus x. 12 plus x. Just two numbers put together. Might be a good idea to put them in parentheses. So when we cross multiply, we remember to put them in parentheses. Questions on the setup? Okay. This one is a little more different, maybe a little more difficult with the cross multiplying, but shouldn't be too bad. Let's do this easy cross first. 35 times x. When I multiply the other cross, I just need to remember to put it in parentheses, just like it says. Trace, any guess on what to do now in terms of the algebra? Yeah, let's distribute the 20. Keep on going. Try to do the algebra on your own and then look up. Okay. On this one, what you got? If you're struggling with cross multiplying, let me know. I can give you a pass for advisory. Usually this is the hardest part for students to figure out. And then the cross multiplying is a little easier. But everybody's different. Let me go through the steps real quick of what we did on this problem. First, we proved they're similar so that we could then compare. So we did our comparison. We decided to start with 20 in the small triangle. Then we picked what goes with it in the larger triangle. Back to the small triangle, back to the big triangle. Once you have that set up, you're ready for algebra, cross multiply. Any questions before we do one more? Okay, we're going to do the exact same steps. So let's look at part B. It asks us to find xy. Here is xy. I'm going to call that A. You can pick any letter you want. I don't really want to use X because that's already been chosen in the picture. Before we start comparing sides, let's make sure they are comparable or are similar. Let's do this on your own. Look at the triangles. Determine if they're similar, maybe by AA again. Hopefully you already have this. One angle was given to you. Angle X, marked the same as Q. You should notice vertical. Those are always congruent. I call them angles 1 and 2. These triangles are definitely similar by AA. Now we're going to compare some sides. Lydia, pick a number, or you can pick A if you want. A. Okay. She wants to start with A. Look what A is next to and find what it goes with in the other triangle. Connor, what do you think it goes with? Not sure. Okay, so let's look at where A is. A is next to the angle that has a single arc and the angle that has a double arc. So that can't be 38 because there's a single arc and nothing. So that's got to be 30. Single arc, double arc. Anna, what number would we have to do now? If we started with A here first, what would we have to put up here? 22. Yep, got to go back to the same triangle we started with. There's only one number left, so it should go with 38, but let's double check, make sure we did everything right. 22. The single arc, no arcs marked. 38. Single arc, no arcs. They do go together. Cross multiply. We always want to go through these steps. We want to make sure they're similar. Usually AA comes up a lot. Once they are similar, start with any number you want and compare it to the other triangle. Then some algebra. I'm going to put up your homework. There are 2 questions. Some have parts to them that I really want you to get correct. For B and 5, I want you to attempt every single problem. But if you get stuck, a little confused, that's okay. Hopefully 4B and 5 are perfect. You're doing all of them. We have 15 minutes, so we should not be on our phone. We should be working on this homework. Okay.